Alright, so section 6.4, which is about factoring perfect square trinomials and factoring the difference of two squares, difference or sum of two squares. So the perfect square trinomials, like for instance, if you look at 14, page 470, it's a trinomial. We're still doing trinomials. The only difference is it's going to be factored with the same factor twice. Like if you look at the trinomial x squared plus 14x plus 49, whenever the last term is a perfect square, so what's the square root of 49? The square root of 49, if you do that in your calculator, it's 7. So you suspect it's 7 and 7. So remember how we did product is 49 and sum in this case is 14. The first thing you try is the same number twice, 7 and 7. Do they work? 7 times 7 is what? 49, and 7 plus 7 is 14. So we know it's going to work out that way. So we write x squared, and that's what? 7x plus 7x plus 49, and then do grouping. X plus 7, 7x plus 7. So it's x plus 7, x plus 7. That's what makes it a perfect square, because you can write it as x plus 7 squared. So whenever this number is a perfect square, you square root it and you try that number. And if it's a minus here, it's going to be minus minus. If it's a plus here, it's going to be plus plus. It might not work, but it's worth trying. 22, page 470. X squared plus 10x plus 25. So 25 is a perfect square. If I square root it, I get 5. So I suspect it's 5 and 5 because product is 25 and sum is 10, which fits that. So x squared plus 5x plus 5x, that's how we split the 10x plus 25. X plus 5, 5x plus 5, which is x plus 5, as we suspected, and it's x plus 5 squared. Either one of these answers is fine. Okay? So 26, page 470, d squared minus 10d plus 25. Again, if you do square root of 25, you get 5. So product is 25, but sum is negative 10. That's why we're going to do negative 5, negative 5. Okay? And it's going to be d minus 5. You don't have to do grouping, because if you do grouping, remember how we got x plus 5, x plus 5? Same thing. So it's going to be d minus 5 or d minus 5 squared. Number 30, 25a squared plus 30ab plus 9b squared. It's a trinomial in descending order, but there's two letters. So if you forget about the b like we usually do, square root of 9 is what? 3. And since this has a 25, square root of 25 is 5. So we suspect it's going to be 5a plus 3 and then 5a plus 3. Right? We square root each one of these and then the b. And you can check your work and you can see it's going to work. Okay, so that's basically perfect square trinomials. If you look at 36 from page 471, 4x to the 4 minus 20x cubed plus 25x squared. This one has a greatest common factor first, x squared. So we take that out, we get 4x squared minus 20x plus 25. Again, square root of 25 is 5, and that's 2 and 2, so 2x, and it's a minus 5, and it's a minus 5. And it's minus because of this, okay? So that finishes the first part of 6.4. The second part is about factoring the sum and difference of two squares. Factoring sum and difference of two squares. And these are binomials. So we're not doing trinomials anymore. We're doing two terms. So in chapter 5, we would do something like this: a plus b, a minus b, and we would FOIL it and get the answer, and that's where this rule came from. So a squared minus ab for the outer plus ab for the inner, and then minus b squared for the last. And this is what we call difference of two squares. Obviously, difference for minus and a squared and b squared. So in chapter 6, we're going to reverse that. So how do we factor the difference of two squares? A squared minus b squared. It's going to be, again, it's going to be a plus b, a minus b. So you put one of each, and then the signs, it doesn't matter. It could be minus plus, as long as there's one sign of each. Okay, as long as there's one sign of each. So for example, how do we factor the sum or difference of two squares? If you have x squared minus 4, x squared is obviously a square, 4 is 2 squared. You have a calculator, so if you square root 4, you get 2. That's how you know that. So it fits that, so it's x minus 2, x plus 2. If you do x squared minus 1, we know that square root of 1 is 1, so 1 is 1 square, so it's x minus 1, x plus 1. You can write 1 to any power you want, because it would still be a 1. X squared minus 16, remember for 16 is 4 square, so it's x minus 4, x plus 4. What if I had x squared plus 16, which is x squared plus 4 squared? This cannot be factored, it's prime. It's the sum of squares. So if you have a squared plus b squared, it's prime. Cannot factor that, okay? Okay, example 4. 9x squared minus y squared. If you square root 9 on your calculator, you get 3. So you're going to bundle the 3x together, and then y squared is y squared. Same rule. You do 3x minus y, 3x plus y. If you want to check it, you just FOIL. 4x squared minus 25 y squared. Again, the square root of 4 is 2, so we can write 2x squared. Square root of 25 is 5, so we can bundle the 5y together. And then it's 2x minus 5y, 2x plus 5y. Okay. Example 6, 121 a squared minus 144 b squared. Again, square root of 121 is 11, so we bundle the 11a together. Square root of 144 is 12, so it's 12b squared. And now using that rule, 11a minus 12b, 11a plus 12b. It's very straightforward. Now, example 7, 2a squared minus 200b squared. Now, the only difference here is there's a common factor, and that's what we always have to pull out first. So 2 comes out, and it's a squared minus 100b squared. Square root of 100 is 10, so we can write 10b together, and then a squared is a squared. And then we use that rule, a minus 10b, a plus 10b, and then the 2 comes down. Rule number example number 8, a squared b minus b cubed. We can take out a b, so it's a squared minus b squared, and that's the rule that we've been working on, a minus b, a plus b, and this b comes down. Example 9, 144 a4 plus 169 b4. So that's 12 if you square root it. A squared square. Square root of 169 is 13. If you do b squared square, you get b4. So we bundle these two together, which is the sum of squares. And the sum of squares, as always, is prime. Can't factor that, okay? Alright, next example is page 471. Number 66, page 471, number 66. It's 81 y to the 4 minus 100 z to the second. Again, when we square root 81, we get 9. So y squared square is y to the 4. Square root of 100 is 10, so it's 10z squared. So it's 9y squared minus 10z, and then 9y squared plus 10z. Alright, now we go to 76. If you look at 76 from page 471, it's 25 plus b squared, which is sum of squares, which is prime, as you know. Can't factor that, okay? That's 5 squared plus b squared, so it's prime. Okay, 84, 81 p squared minus 36 pq plus 4q squared. You can see it's a trinomial. So we're gonna remember this is a perfect square and this is a perfect square. So we're gonna do 9p and it's a minus 2q. Square root of 81 is 9. Square root of 4 is 2. We put the q, and then 9p minus 2q. And if you FOIL it, you're gonna see that's gonna work out. Okay, let's look at 96. We have negative 196 plus 49 f squared. So it's probably a good idea to rewrite it as 49f squared minus 196. The square root of 49 is 7, so we bundle these together. Square root of 96 is 14, so it's 14 squared. 7f minus 14, 7s plus 14. And that ends 6.4.